Given point P minus 2, 6, 3 and vector A is equal to y ax plus x plus z ay, express P and A in cylindrical and spherical coordinates. Evaluate A at P in the Cartesian cylindrical and spherical systems. Question. Given point is P, that is at minus 2, 6, 3, and the vector at this point is given as vector A is equal to yax plus x plus z ay. Okay, so in our question what we have to find is, we have to convert from, this is in Cartesian system, from the question we have to identify this is in Cartesian system. So we have to convert this point and this vector in Cartesian system into cylindrical and spherical system. Okay, so first we have to convert this point into cylindrical coordinates and spherical coordinates, and next we have to convert this vector in Cartesian system into spherical system and a cylindrical system. Clear? So first we can convert this point P. So at this point P, what is the value of the Cartesian coordinates? We can write at point P, Cartesian coordinates we know, that is x, y and z. So at x is minus 2, that is given, and y is 6 and z is 3. Okay. Okay. So at this point P, x equal to minus 2, y equal to 6 and z equal to 3. So we have to convert it into cylindrical coordinate. So by applying the equation, rho is equal to square root of x square plus y square. So you will get, substitute the values of x and y. So minus 2 the whole square plus 6 square. So you will get us 6.32 as rho. Then what about this next coordinate is 5. 5 can be found by tan inverse y by x, which is equal to tan inverse y is 6, x is minus 2. So you will get as minus 71.56 degrees. So it is the negative of angle, that is from the y-axis. When you draw this axis z and this is y and this x, so this is our rho. So what we got is, this angle is minus 71, that is from this is rho, so this is minus 71.56 degree. But we want from the x-axis, so we have to find phi will be equal to 180 plus minus 71.56 degrees. So that is equal to 108.43 degrees. Next coordinate is z, that is will be same as in Cartesian coordinate, z equal to 3 itself. Now next we have to convert it into spherical coordinate system. So next we have to convert it into spherical system. So how we can convert from Cartesian to spherical system? We can apply the equation r is equal to square root of x square plus y square plus z square, which is equal to square root of x is minus 2 the whole square plus 6 square plus 3 square. So you will get us 7. Okay. Now that is the r. Next we can find theta. How we can find theta? Theta will be equal to tan inverse square root of x square plus y square divided by z, which is equal to tan inverse square root of, that is minus 2 square plus z is y is 6 square divided by z equal to 3. So you will get us the angle as 64.62 degrees. And phi we already found out in cylindrical system, that is phi is equal to 108.43 degree, that we already found out. So these are the 3 coordinates in the spherical system also. Next we have to convert it into this vector A in Cartesian system into cylindrical and spherical system. So first we can convert from Cartesian vector into cylindrical vector. So we already studied the transformation matrix or transformation equation. We have to convert from Cartesian to cylindrical. So we can apply this transformation, that is a rho a phi a z will be equal to cos phi sin phi 0 minus sin phi cos phi 0 0 0 1. Then here we can write the Cartesian vectors that is given in the question, that is ax, ay, az. Okay. ഇവിടെ നമുക്ക് we got the at this point P, the vector is A. So we can substitute the value of y and x plus z here. So we can write the vector A at point P will be written as A is equal to y is 6ax plus x plus z is minus 2 plus 3. Minus 2 on x plus z is 3 into ay. So this will be 6ax plus ay. Okay. So we can substitute the coefficient of this vector. This ax and ay, we know that is unit vectors. The coefficient of these two vectors we have to substitute in the matrix. So we can write the matrix again. This a rho a phi a z will be equal to cos phi sin phi 0 minus sin phi cos phi 0 0 0 1. What is ax? Capital Ax is coefficient of that. This ax is 6 and coefficient of this ay, that is 1. Then here coefficient of az, there is no coefficient of az compound ഇവിടെ ഇല്ല, so that becomes 0. Okay, so we can multiply this matrix and we can find the answer. In matrix form we can write this one and we can multiply this matrix. Cos phi into 6 plus sin phi into 1, this is 0, that will be the a rho. Then minus sin phi into 6 plus cos phi into 1 will be the a phi. Then az will be 0 into 6 plus 0 into 1 plus 0. So the az will be get as 0. So you can write this a rho as a rho will be equals, multiply this matrix, cos phi into 6 cos phi plus sin phi into 1, that is sin phi, 0 into 0, that is 0. So substitute the value of phi here. So you can find the answer of a rho. Then a phi will be minus sin phi minus 6 sin phi plus cos phi, that is find the value of, substitute the value of phi and find the answer. Then az is, then substitute 6 into 0, that is 0, 0 into 1, that is 0, 1 into 0, that is 0, so az becomes 0. So substitute the value, you can find the value of a rho, a phi and az. So we got the value of a rho will be, substitute the value of phi here. So a rho you will get as minus 0.9487 and a phi you will get as minus 6.008. Now we have to write the vector in cylindrical system. A is equal to vector A in cylindrical system. Vector A can be written as this coefficient of this a rho is minus 0.9487 a rho, unit vector a rho. Then coefficient of a phi is minus 6.008 minus 6.008 a phi. Az is 0, so no need to write. So the cylindrical system, the vector A is minus 0.9487 a rho minus 6.008 a phi. Similarly, we have to convert from Cartesian vector into spherical vector. So we can apply this transformation. So we already found out this transformation, that is in Cartesian into spherical system we have to convert from this Cartesian vectors. So we already found out the Cartesian vectors as the coefficient of all these ax and ay and az, that is 6, 1 and 0. Already we know that. Then transformation matrix we have to write here. Now we can multiply the matrix and we can find the answer of AR, A theta and A phi. So what is AR? Multiply this matrix, first row into this column. So sin theta cos phi. Sin theta cos phi into 6. So there is 6 sin theta cos phi. Then this is plus sin theta sin phi. This is cos theta and 0, that is 0. Then what is next is A theta. Next vector A theta can be found by cos theta cos phi into 6. So this becomes 6 cos theta cos phi plus this is cos theta sin phi, cos theta sin phi, this is 0. Next last vector A phi will be equals minus sin phi into 6. So minus 6 sin phi plus cos phi, this is 0. Okay, so similarly you can write AR, A theta and A phi. Substitute the value of theta and phi here. Theta we already found out and phi also we already found out in the spherical system. Substitute the values of theta and phi here and multiply and add. So we will get the answer as AR, A theta and A phi. So you will multiply substitute the values of theta and phi. You will get the value of AR is minus 0.857 and A theta is minus 0.406 and A phi is minus 6.008. Now we can write this vector A in spherical as A is equal to minus 0.857 AR, that is unit vector AR. Then this next is minus 0.406 A theta, then minus 6.008 A phi. So this is the vector in spherical system. So we have to, after finding this answer, we have to write the final answer of vector A is minus 0.857 AR minus 0.406 A theta minus 6.008 A phi. Express vector B is equal to 10 by R AR plus R cos theta A theta plus A phi in Cartesian and cylindrical coordinates. Find B at minus 340 and B at 5 pi by 2 minus 2. So in this question, we have given the vector B is equal to 10 by R AR plus R cos theta A theta plus A phi. So from this vector we can find this is a spherical system vector. Okay, what is our aim? We have to find the vector in Cartesian system and the vector in cylindrical system. So first point we have given is find the vector B at this point minus 340. So this is a vector in Cartesian system. So at this point we have to find the vector B in Cartesian system. So what we have to find? First we can find the Cartesian coordinates. From this Cartesian coordinates is given, we can find the spherical coordinates at this point. So we know that all these points, Cartesian point at this point B minus 340, this will be same as the point at spherical and point at cylindrical. First we can find similar to this point in Cartesian system, we can find a similar point in the spherical system. So how we can convert from Cartesian into spherical? We know the equation R is equal to square root of x square plus y square plus z square. Substitute the coordinates. X is minus 3 the whole square plus this y is 4 square, z is 0 square. So the R is, we will get as 5. Now we have to find the next coordinate is theta. We know that tan inverse square root of s square plus y square by z. That will be equal to tan inverse square root of x is minus 3 the square, y is 4 square, divided by z is 0. So this angle, we know that tan inverse of this value will be equal to 90 degrees, because tan inverse of this value by 0 means tan inverse of infinity. So that will be, we know that that angle is 90 degree. Then next we can find what is phi. Phi will be equals tan inverse y by x. Tan inverse y by x means tan inverse y is 4 by minus 3. So this value is, we take the tan inverse, we will get that is 126.86 degrees. So all the r, theta and phi spherical coordinates at this point b minus 340 will get, that is Cartesian system minus 340, this will be same as in spherical system. This coordinates 5, 90 degree and 126.86 degrees. Both will be same. And the point at the Cartesian system will be same. This will be same as the point at this spherical system. So we found out the spherical coordinates r, theta and phi. Next we have to find the spherical system vector into Cartesian vector. We have to find the Cartesian vector from this spherical vector. Spherical vector is given in the question. We have to convert it into cylindrical vectors. That is, we have to find this bx, by and bz. That is our aim. Okay. So this transformation equation we have to apply here in order to convert from spherical system into cylindrical system. Okay. So in this question, what is BR? BR is this 10 by R. This is BR. And what is B theta? And coefficient of this A theta is B theta. This is B theta. And what is B phi? B phi is here coefficient of A phi. That is, here it is 1. Okay. So 1 is the B phi. So we can substitute these values here. So we will write the transformation as again sin theta cos phi, then cos theta cos phi minus sin phi. Next is sin theta sin phi cos theta sin phi cos phi. Next is cos theta minus sin theta 0. BR is, that is 10 by R. And what is B theta? That is R cos theta. Then B phi is 1. Now again we can substitute the value of R here and theta here. And we can find the answer of this bx and by and bz. So we will get as bx will be equal to R. We know that is R, the value of R is, we already found out that R is equal to, we found out that is 5. And what is the value of theta? Theta is 90 degree, we found out. And what is the value of phi? That is 126.86 degrees. Substitute all these values in this transformation matrix. And here we have to substitute the R equal to 5. We can substitute 10 by 5. That is equal to, this will be 2. And here we can substitute here R cos theta also, we can substitute it is R equal to 5. So become 5 cos theta. And substitute all the values of theta and phi here and multiply this matrix. So you will get final answer of bx will be equal to minus 2 and by you will get as 1 and bz you will get as 0. Okay. Now we have to write the vector in Cartesian system. B will be written as minus 2 ax plus ay. The coefficient of az is 0. So no need to write that. So finally we have to write the vector in Cartesian system is minus 2 ax plus ay. Next we have to convert from spherical system into cylindrical system. So we have to find a point at point B, that is at cylindrical point at B, 5 pi by 2 minus 2. We have to find the vector B. So in order to find the vector B, we have to find the coordinates of cylindrical coordinates rho, theta and phi. So how we can find rho, theta and phi? That is given in the question. That is rho is 5. Here rho is 5 at cylindrical system, and pi by 2, that is there is 5, and this is minus 2, that is z. Okay. So this is the cylindrical coordinates. So we have to convert it into, first we have to find the spherical coordinates. So how we can find spherical coordinates? R is equal to square root of, we already found out what is R in terms of cylindrical coordinates, that is R equal to rho square plus z square. So what is the value of rho square plus z square, and which is equal to, what is rho? That is 5 square plus z is equal to minus 2 the square. So you will get as root 29. Then what is value of theta? Theta will be equal to tan inverse rho by z. In cylindrical form, also cylindrical coordinates also we can find theta, that is tan inverse rho by z. That is tan inverse, what is rho? The value of rho will be 5 and z will be minus 2. So you will get as theta will be equal to tan inverse 5 by minus 2. The value of theta will be tan inverse 5 by minus 2, which is equal to minus 68.1 degrees. This can be written as 180 plus minus of 68.1. So you will get as 111.9 degrees theta. Okay. Phi will be same as in the cylindrical system. Phi is given in the cylindrical system as pi by 2. So this pi is also pi by 2, which is, we know that is 90 degrees. Okay. So the spherical coordinates we got. Now we have to apply the transformation matrix for converting from spherical vector into cylindrical vector. So the transformation we have to apply here from spherical to cylindrical is b rho, b phi and b z will be equal to the sin theta cos theta 0, 0, 0, 1, cos theta minus sin theta 0, b r, b theta and b phi. Now we can substitute the value of this coefficients of this spherical vectors b r, b theta and b phi. Again this can be written as sin theta cos theta 0, 0, 0, 1, cos theta minus sin theta 0. Okay, BR will be, what is BR? That is 10 by R. Then what is B theta? That is R cos theta. And what is B phi? That is 1. Now what is the value of R we found out? R we found out as, from cylindrical coordinates into spherical coordinates we convert, and we found out R as root of 29. And what is value of theta we found out? Theta we found out as 111.9 degrees. And phi is same as this phi, that is pi by 2 or 90 degrees. Okay, substitute the values of here. This R is here 10 by root 29, 10 by root 29. Here also R is root 29, root 29. Okay. Now substitute the value of theta here. Sine of this angle 111.9 degrees. So you will get the value of all this b rho, b phi and bz. So substitute the value of theta here in the matrix and multiply this matrix. So we will get b rho will be equal to, first row into this column we will get b rho will be equal to 2.467 and b phi will be equal to, multiply this row with this. So this 1 and 1, b phi will be 1 and bz will be, multiply this third row with this column. So you will get bz will be equal to 1.167. So these vectors coefficients are in cylindrical system. So we have to write the cylindrical vector b will be equal to coefficient of b rho, that is 2.467 a rho plus b phi is 1. So that is a phi plus bz is 1.167 az. So the final answer will be this one. Okay.